Alrighty, happy Thursday, 7th graders. This is Mrs. Oliver bringing you today's reteaching on the constant rate of change. This is also known as CROC if you just do the acronym of the CROC. Alright, so we have a little bit of review. We're going to fill in some tables, and then we have a little bit more stuff to do. Alright, and then whatever I don't do in this video is what you are required to finish up for your assignment. So we need to fill in these word problems, making the tables that are set up for us with already our x's and y's determined for us. Okay, so a swimming pool is being refilled for the summer. It currently has 100 gallons of water in it. It's being refilled at a rate of 25 gallons per minute. Complete the table to represent the relationship. We should always start with 0. Where are we starting at? And then we want to increase by per minute. So we have our 1 minute mark, 2 minute mark, and 3 minute mark. Okay. So what did it tell us? It told us it already currently has, before they even start putting more water in it, the 100 gallons. So that's how we know 100 goes here. Then each minute as it passes, we are adding 25 more gallons to the pool. So we're going to add 25 to our 100. Give me 125. Then for our 2 minute mark, we have 150 gallons. And we're going to end at the 3 minute mark with 175 gallons in the pool. That's all we needed to do for the top 4 that we're trying to do. Okay. 3 is a little bit different than the other ones. Okay. So a car is traveling at a rate of 40 miles per hour. Okay. So that tells us that we're just increasing by 40. Okay. So if I haven't moved, am I going any speed at all? No. Okay. But after 1 hour, since I'm going 40 miles per hour, that's my 40. Then 2, I have 80. And 3, I have gone 120 miles. Okay, so do the other 2 ones. Read them carefully of where you're starting at and what are you adding each time for either your feet and savings. Okay. All right. Directions. We are going to determine whether a relationship between 2 quantities shown in each table is proportional and has a constant rate of change. And if so, we need to determine what is the constant rate of change. Then write the equation for the relationship. Okay, so we have this, we have 4 here. On the other side, we have graphs that we will look at. So I will do 2 of these. I'm going to do 5 and 7, and then you're going to have to do 6 and 8. All right. So first thing we want to look, is it proportional? Well, remember, to find out if it is proportional, we have to take our y and divide it by x. Okay. Once we do that, then we can determine. Now, well, which one's x and which one's y? Well, if you remember, x is always on the left, y is always on the right. So we want to take our cost and we're going to divide it by 5 to see what we get. So 325 divided between 5 people, 5 goes into 32. 6 times, with 2 left over, get 65. All right, so now take our 650. We're going to divide by 10, which means I got to move my decimal over 1 time. I get 65. Remember, you have to do all of these to make sure that it's proportional. All right, so now I'm going to take my 975. Divide that by 15. And I get our 0.65. And last one, 13 divided by 20. And we get that they're all 65. Now remember, that tells me it's because they are all reduced to 6500s. Yes, it is proportional. Okay. And if it's proportional, it automatically, yes, we know for sure it has a constant rate of change. The constant rate of change is what number did they all reduce to? Well, my 6500s. Each time is what they're adding. Right? So then what is my equation? Well, that means this is my k, and my y equals kx. I wanted to color code that way. Let's erase it. So in my equation, y equals something times x. I'm bringing this down in there. Okay, you're always going to have your y equals something with x if it has your constant rate of change. Okay. All right, let's look at, I'm going to do 6. Let's not do 5 or 7, I mean. We already did 5. Okay, so remember we are taking each of these and we're going to take our y and divide it by that. Now I can't divide by 0, I get undefined. Okay, so that one is undefined. But that means when x is 0, my y is at 12. Okay, now take that and divide by 3. So 17 divided by 3 is 5 and 6 repeating, or 5 and 2/3. Take your 22, divide by 6, and we get 3 and 2 repeating. Are those the same number? I already have 5, 3, undefined. It's not at 0, 0, so it's not crossing the origin. So this one is no, that it's not proportional. Now, that does not automatically mean that there is no constant rate of change. Remember, constant rate of change, we look and see how are we increasing or decreasing for y over how are we increasing or decreasing for x. Okay, so my change in y over my change in x. So each time here, well, 12 to 17 is 5. 17 plus 20 to 22 is 5. So I added 5. I added 5. And 22 to 27. Now, if you can't figure out how you got there, take the highest number and subtract. You can work backwards. Take 27 minus 22. That gives me 5. All right, so my change in y is consistently 5. Now, if these were not consistent, we would not have a constant rate of change because that's the whole point, being constant. All right, so 9 minus 6, 3. 6 minus 3, we added 3. 3 minus 0 is 3. So yes, we have a constant rate of change. We consistently change. Even though it's not proportional, it's still a straight line, so it is a constant rate of change. All right, so what was my constant rate of change? The constant proportionality we have is 5. So then when I go to write my equation, I look, y equals, and I want to plug in this number in front of x. All right, so for every tablespoon, we multiplied it times this fraction to get these answers. That's how the equation works. I wanted to plug in 9 for x. 9 times 5/3 is 27. All right, scroll or flip over to your next page. Determine if the relationship displayed on the graph is proportional. Does it have a constant rate of change? If so, write the equation representing the relationship. All right, so we have to look. 1, what are the criteria for to have a constant or to have a proportional graph? We know 2 things. It has to be a straight line. Oops. And it has to cross the origin which is at 0, 0. Okay, so let's look. Is it a straight line? Yes. Does it cross at my origin? No. So that tells me already it's not proportional. But does it have a constant rate of change? Is it consistently going up and over with our rise and run at a constant rate? So if I look here, I went up 2 and then I ran 2. So our slope we know is 2 over 2. Well, that reduces to 1. So yes, we have a constant rate of change. My staircases are even. They go the same way every time. And that means this is 1. Now there is a way to write an equation. Right? So we still use y equals kx. I'm going to throw something else at you. And this, you'll get more into this in 8th grade. But our plus b is wherever it crosses at the y-axis. Okay, so that means I have y equals my 1x plus my 2. Okay, but look, even though it's not proportional, it's a straight line. It is consistently changing. So that's why we say it does have a constant rate of change, because it is the same every time. All right, let's look at the next one. Is it a straight line? Yup. Does it cross at an origin? Yup. Is it proportional? Yes. All right, our next thing. What is the constant rate of change? We know if it's proportional, automatically there has to be a constant rate of change. So now we have to find it. Okay, so I look, how am I rising and how am I running each time? Well, I went from 3 to 6. That's my bottom number. So that means I ran 3. And I only went from 0 to 1. So that means that my slope, my rise over run, was 1/3. So that is how we are constantly changing our graph. So 1/3 is my constant rate of change. Then all we have to do is write our equation. Take your 1/3, plug it in, y equals 1/3 x. And the reason why we don't have to add anything is, where did we cross the at the origin? We crossed at 0, 0. Do we need to put plus 0? No. So that's why this one looks different than that one. Okay, so then you just need to finish this up. You have to create a table that does not have a proportional relationship, but does have a constant rate of change. So that means each time you're adding the same number. Okay, then write the story problem that goes with the table. Okay, so if you need to, if it's easier to write the story problem than the table, you can pop, that should be worthy too. Okay, have a great day, make good choices, and get those assignments turned in. And have a great Friday, because that is tomorrow.